All right, algebra 2. Let's go ahead and talk about rationalizing denominators when they have square roots in denominators, right? So this terminology, this idea of rationalizing the denominator, means that we're pretty much getting rid of the square root in the denominator and replacing it with a whole number, okay? Let's see how we can do that. Let's look at this first one. Okay, so first let's apply our quotient property. So that's square root of 9 over square root of 8. That's going to be 3 over the square root of 8. Now let's go ahead and try rationalizing this as we see that there is a radical 8 in the denominator. Okay, the way we're going to do it is think about how we can get rid of that, quote unquote, get rid of that radical. If I take square root of 8 and I multiply it by square root of 8, I get square root of 64, which is just 8. Right? So whenever we have a square root standing alone in the denominator, the way we're going to rationalize is by multiplying it by itself, but then we can't break the rules of math, so we also multiply the numerator by the square root of 8, right? And this is okay because this is just like multiplying by 1. So let's see what happens when we do that. We get 3 radical 8 divided by 8 times 8 under the radical, which we just said is square root of 64, which is 8. Okay, so square root of 64, which is 3 rad 8 divided by 8. Okay, and now there's one last thing we got to do. Can we simplify the rad 8? Yes, we can actually. Notice that rad 8, the biggest perfect square that can divide into 8 is 4. 4 times 2. We can use our product property to simplify that down to 3 times 2 rad 2 over 8. So I get 6 rad 2 over 8. And then there's one last thing we can do to simplify. 6/8, that's actually 3 rad 8 over 4. Okay, so there is our simplified radical. Simplified and rationalized. Okay, so we pretty much just found out that 3 over rad 8, these two things are the same. Okay, so those are the same thing, but this tells us a little bit more about the number. I know how fourths work, and if I'm ever in the need to add or subtract fractions, adding and subtracting fractions with just the whole number in the denominator is a little bit easier than dealing with the radical. So that's the whole point of rationalizing, or one of the points of rationalizing. Okay, now what happens when we have this going on? We have something plus something, at least one of those somethings being a radical. Both of these can be a radical, or in this case, one of them can be a radical. Whenever that happens, we're going to use what's called a conjugate. Okay, and what the conjugate does is it's the same thing. It's going to be 4 rad 11, but I'm just changing the sign in the sign that's being used, the operation. Just the middle one. If this was -4, I would leave it as -4. I'm only changing the middle one. Okay, and that's what the conjugate is. It's the same two values, but with a different sign in between, a different operation. Okay, so if this, let me go ahead and erase. If this started off as minus, if this is 4 minus rad 11, then I would do 4 plus rad 11. Okay? That's what the conjugate is. So what we're going to do is multiply by the conjugate. Same thing though, what we have to do is multiply top and bottom by the conjugate. Now you're looking at this and you're probably thinking that looks disgusting, Mr. G. Don't fear. Notice that this is a special pattern, right? We can apply the factoring patterns here. Look, this is technically A plus B, and this is A minus B. When you multiply those two things, what do you get? A squared minus B squared. So I can rewrite it as such. I'll do the numerator first. We'll deal with that afterwards. 2 times 4 minus rad 11 in my numerator. Denominator, a is 4, so 16. B is square root of 11. Square root of 11 times square root of 11 is 11. So minus 11. And we just avoided doing distribution. Good for us. Simplify, simplify, simplify. Distribute our 2. We get 8 minus 2 rad 11 over 16 minus 11. That's 5. There is our rationalized quantity. Okay, hopefully that sounds pretty good. Let's go ahead and apply some of this stuff to solving quadratic equations. All right, so the name of the game when we're solving quadratic equations is we want to get the squared thing by itself. So then we can take a square root. Example A, or part A of this example 3. We have x squared is equal to 35. Once it's in this form, once it looks something like this, I can go ahead and square root both sides. But when I do the operation of square rooting, remember from algebra, and hopefully also from geometry, we got to impose the plus minus 5, the plus minus. And that's kind of from up in the beginning of the lesson when we talked about it. When you are asking yourself about the square root of something, I can square the positive number and the negative number and I'll still get 35, okay? So on the left-hand side, square rooting a square, those undo each other, those are inverse operations. So I get x is equal to plus or minus square root of 35. Before you circle your answer, ask yourself, can we simplify rad 35? The answer is no, because there's no perfect square that goes into 35. And if you think about it, the only factors are 7 and 5. I can't really do any much with those, right? So we don't need to keep going. Okay. Next one, let's try 3x squared plus 5 equals 41. We got to get the squared thing by itself. We got to get x squared alone. So let's start. Minus 5 on each side. 3x squared is equal to 41 minus 5. That's going to be 36. Divide each side by 3. That's going to be x squared equals 12. And now squared thing is alone. X squared is alone. I can square root both sides with my plus minus right here. Don't forget about your good old pal, the plus minus. Square root undoes the square. X is equal to plus minus. How can I simplify rad 12? Well, I know that's rad 4 times rad 3. So it's 2 rad 3. So I get plus minus 2 rad 3. Yay. 2 more. Okay. And then actually, we'll go ahead. That way the videos are a little balanced. We'll save that to part 3. Okay. So see you in part 3.